Hello, my name is Amin Iskandar, and today I will be showing you how to calculate the confidence interval when using a small set of measurements, as well as how to simulate a bell curve when using a large number of measurements. So we will be doing this by answering this question. So for the first question, it's asking us whether these two measurements are the same or different, and they're only giving us the mean plus the standard deviation and the number of measurements. So to do this, because we have a small number of measurements, we will use the confidence limit equation, which is this one, and it's located in the Analytical Chemistry book in the 7th edition on page 84. So let's enter our values over here under these cells. So for the X bar, it's the mean value, and for our first one, it's 234.10, and our second one is 237.1. Our standard deviation is 0.0 for our first one, and for our second one, it's 1.1, and the t-tab is the value we get from the table, which is also located on the same page 84, and you always want to subtract 1 from the number of measurements. So for example, in our question we have n equals 4, so for our degrees of freedom it will be 4 minus 1, and to look at the 95% confidence level it will be 3.812. And our second one, n equals 8, and we subtract 1, it will be 7, and at 95% confidence level it will be 2.365. And to calculate the limit we will use this equation above. So you're going to multiply the standard deviation times the tab divided by the square root of the number of measurements. And for our lower bound, we're gonna subtract the mean value minus the limit. So it will be 234 minus this number we calculated, and the same thing over here. And for our upper bound, we're gonna be adding our average plus the limit. So as a result of our calculations, at 95% confidence level, the true value of these two measurements did not overlay, therefore they are different. So when you're determining whether they are different or the same, you're always looking at the lower bound and the upper bound and comparing the true value. So our final answer would be Now for our second question, it's asking us after doing these problems, we found that someone really screwed up typing, and it should have read this average plus with this standard deviation, and it gave us a huge amount of measurement, as well as another average with the standard deviation, and even bigger amount of measurement. So to determine if they are the sameness of these measurements, we will simulate two bell curves, and by doing this we will go to the next sheet. The first thing to do when you simulate a bell curve is to create a bend, because Excel will ask us for bend numbers, and bend numbers are those that represent the interval that you want the histogram tool to use of measuring the input data in the data analysis bar, which we will do in just a minute. So for the calculations of the bend number, For the first one, you set it equal to the average minus 10 times the standard deviation. And what's happening here is this formula is generating the average and standard deviation for the original data. And like I said, this first cell is also generating the lower limit of the Bell range, which represents 10 standard deviation less than the average. And that's why we put minus 10. For our second formula, it's going to be basically adding 1 standard deviation to the number calculated in this cell above. And we continue shifting this for each cell until we reach a 20 of standard deviation, because this is what the question is asking us over here. It's asking us to have a span of at least 20 standard deviation. So by doing this, we will add the standard deviation, and you always want to lock it because you're going to be using the same number for 20 standard deviation, and then plus the number right above it, which is B8. And let's do that again for the second one. And we're gonna add it with the number right above it, and make sure to always lock the standard deviation. And let's highlight these last two columns and then drag it down all the way to 27. And there we have our bin number for our first standard deviation and average. And let's do the same thing over here for our second set of values. So like I said, for the first bin number, we will subtract the average minus 10 and multiply it by the standard deviation. And for our second one, we're going to be adding the standard deviation and make sure to lock it. And then plus the number right above it. Let's do that again for another one. Now highlight these last two columns and drag it down all the way to 27. Now we have our bin values for both of our set of measurements. So now to do the to create random numbers within the data, you need to have the data analysis in the data tool Excel. So first we're going to go to data and then data analysis. And then click on random number generation. And for our number of variables, for our first one, it's 4,000. And I'm getting this number by looking at the number of measurements. And the number of random numbers, we want it just one. And we don't want a discrete distribution, we want a normal one. Oops. And type in the mean value. In this case, it's 234.1 and 1.9. And click on output range, and you could select the arrow key by selecting the cell where you want the random values to be placed in. And then OK. Now you see you have it in a horizontal way, and that's not what we want. So to fix this, press on Ctrl C and then go to the next row and Ctrl V. And now we want to delete this. So press on Ctrl Shift and then right arrow and then right click, delete. So right now we have it also as a horizontal way. So what you could do is click on the control button at the right hand side So Control Shift right key. Oh, what happened? And then right click, and then you see the paste options. We want it as a transpose so it could be vertical wise. Before we do that, let's actually delete this row. Okay, so after you paste it to the next row, click on the one we pasted to the next row, and then there's a control button at the right hand side, and then click on that, and then we want it as a transpose to be vertical. Now we have it in vertical wise, so now we want to delete the row. So you press Control Shift button and then right arrow, and it will highlight the whole row, and then we want to delete it. Now we have our random values for our first one. Let's do that again for our second one. So for random, you go to data analysis, and then random number generating. And now for this time, we want our number of values to be 8,000 because this is the number of measurements for our second one. And you always want to change the mean value because it's different. And our standard deviation for this one is 1.1. And for our output range, I want it to be in this column. Now we have it in a row wise, so what we can do also is Control C, and then go to the next row, Control V, and then click on the right hand side of Control button, and then we want it as a transpose. Now to delete the first row, Control Shift and right arrow, right click and delete. Now we made our random values for both of them. Now to do the histogram, you also go to the data analysis and click on histogram. And for our input range, we want to select the random values. So you could highlight this whole column. And the bin range, you highlight the bin column. And for the output range, I want it in this area. And then click on OK. And now you have a column of bin and the frequencies. Now let's do that again for our second set of measurements. So data analysis, histogram, and our input range changes this time. In our bin range, we want to highlight this column. And for the output range, we want it to be over here, and then click on OK. And now we have our bin and frequency for the two set of measurements. Now the next thing to do is to create a normal distribution curve, and by doing this we're going to go to Insert and then click on Scatter, and we want it with smooth lines. And now we have an empty one. Then right click and then go to Select Data and Add. And for our first series name, let's call it Measurement 1. And our X value will be our bin. And the Y value will be the frequency. Now let's add our second set of measurements. So we'll call this Measurement 2. And now we have our two bell curves for our two set of measurements. Now we want to have a legend so we could differentiate between measurement 1 and measurement 2. Now we also haven't answered the question yet. This question is asking us, what can you say about the sameness of these measurements? To look at our normal distribution curve, we can see that they are overlaid together. So we can type in that they are overlaid. Now to confirm our answers, we will use the percent of normal distribution overlapping another, which is this one. Now to do this, we have to divide the standard deviation of the first one divided by the standard deviation of the second one divided by the standard deviation of the first one. And for our second one, we're going to be subtracting the mean value of our first data. Make sure you set it equal to minus the mean value of our second data, and then divided by the standard deviation. And we will use these two numbers to see whether they overlap, at what percent they overlap. So our y value, it's going to be around 1.7. So you could draw a line shape around 1.7. And our x value, which we calculated above, will be 2.7. So you can draw a line around 2.7 for your x values. Now to confirm with our answer about whether these measurements are the same, we can conclude that they have a 30% overlap with each other. So our final answer would be they And now we have answered both of our questions. So when they're giving you a small set of measurements, make sure to use the confidence interval equation to see whether they are the same or different. And when they're giving you a huge number of measurements, make sure to use the histogram and doing what we did to see whether they have an overlap or not. I hope this video was helpful, and I hope now you understand how to simulate bell curves and how to calculate the confidence interval. Thank you for watching.